So in this course, we're going to be using hand rules in order to determine the direction of force. And there's three factors that we're always going to need to take a look at. One is what type of charge are we looking at? If we're looking at a positive charge, then we're going to be using our right hand rule. But if we're looking at negative charge, then we're going to be using our left hand rule. We also need to know the speed of the charge. So we're going to point the direction in movement of the charge. Yet again, if we have a dot like this means it's coming towards. And if we have something that looks like this, then it's moving away. And the last part is the direction of magnetic field. We're going to use our straight fingers, and our fingers point from north to south. The direction of magnetic force is your palm. So let's do an example right now. Let's say right now I had a magnetic field from here to here, and I had this, and we're going to say this represents electron flow. So all of a sudden, we now know I need to be using my left-hand rule. So electricity is going towards me. And I can see I have a magnetic field that's going to look like this. So look at your left hand. And what I want you to do at home is I want you to look at your hand so that your thumb is pointing towards you. Now your fingers should be pointing to the right because your fingers are pointing from north to south. What you want to look at is your palm. And what you see is that your palm is facing this way. Therefore, we know this is the direction of magnetic force. Let's try one more time. This time, I am going to look at the movement of a proton. So let's say I had a proton and it was yet again moving towards me. And yet again, I'm going to have my north end right here. And I'm going to have my south end right here. So yet again, because we have positive charge, we're going to be using our right hand. So in this particular case, our fingers still need to point north to south. Now, if you look at your right hand and you point your fingers to the right, what you're going to notice in this case is that our magnetic field now is pointing upwards. So you need to look at the context of each question in order to figure out which hand rule to use. Now, we don't just want qualitative observations, we also want quantitative information or observations. And if we want to figure out the magnetic field, well, we just need to know the three things. We need to know Q, the charge of the particle, the speed of the particle, and B. This is a new variable here, and this represents magnetic field strength. And this is measured in T for Teslas. The last idea is we always need to make sure that our movement, speed of the movement of the charge, and the direction of the magnetic field are 90 degrees from one another. So if you look at your hand and either left or right hand, and you see the shape of an L, you'll see that's a 90-degree angle. So typically what we're going to be working with is sine 90. And if you put sine 90 into your calculator, you see it'll equal 1. So we add that in there in case our movement isn't perpendicular to our magnetic field.